British Airways CEO just made a shocking move after discovering a secret that's been quietly bleeding the company from the inside. One finding flipped years of confidence into pure panic almost overnight. And now the decision on his desk isn't about growth or profit, it's about survival. Because for years, British Airways built its long-haul future on one name, the Boeing 787 Dreamliner. It wasn't just another aircraft in the hangar, it was the crown jewel of their fleet. Sleek, fuel-efficient, and packed with technology, Boeing sold it as a machine that could think ahead of the pilot. The airline doubled down on that promise, pouring billions into expanding the fleet, locking in orders and proudly calling the Dreamliner the flagship of the skies. But all it took was one flight, one quiet June morning to prove that this so-called flagship wasn't as flawless as everyone believed. CEO Alex Cruz often stood in front of cameras praising it as the perfect blend of comfort and innovation. Passengers loved the quieter cabins, smoother rides, and the feeling of flying on something truly next generation. Everything about the 787 screamed reliability, until a single morning in June shattered that illusion. On June 8, 2025, Flight BA217 rolled out of Heathrow bound for Washington, D.C. The weather was calm, the flight was routine, and everything pointed to another uneventful crossing. Then, 43 minutes into the climb, something went wrong. The jet stopped gaining altitude. A subtle vibration turned into a shudder that rippled through the fuselage. Speed began to bleed away. The cockpit lit up in tension, if not in alarms. Fuel was dumped, a mayday was called, and the nose turned back toward London. To passengers, the announcement was mild. A technical anomaly, maybe a jammed flap, nothing to panic over. But within British Airways, the tone was far less casual. Whatever had happened wasn't supposed to happen. Not to this aircraft, not with its reputation. And it wasn't the kind of problem you could fix with a quick reset on the ground. Engineers were still digging through the data when, just 2 weeks later, another Dreamliner in the same fleet failed in an entirely different but equally unsettling way. This time, the trouble started before the plane had even left the gate. If one mid-air scare wasn't enough, the next breakdown hit even harder. This time before the Dreamliner could even leave the ground. During pushback, the cabin lights flickered out, the engines refused to spool up, and the avionics, the aircraft's entire electronic brain, restarted themselves in the middle of taxi. The crew aborted the flight on the spot. Passengers grumbled, staff scrambled, and somewhere in BA's maintenance offices, alarm bells started ringing. 2 serious incidents in such a short time, on aircraft that were supposed to be the most dependable in the sky, was no coincidence. At least, that's what the engineers started to suspect. The 787 wasn't just hitting a bump in the road, it was starting to show a pattern. And patterns in aviation aren't just inconvenient, they're dangerous. Behind closed doors, the technical teams began treating the situation as a fleet-wide concern. They weren't looking at isolated faults anymore. They were looking for a thread that connected both incidents, something buried deep enough that no one had spotted it until now. And that's when the CEO's perspective began to shift. Because when the engineers finally traced the thread, what they uncovered wasn't just a glitch. What British Airways engineers found in the weeks after the BA217 incident went far beyond the kind of fault anyone expects from a flagship jet. The data review showed that just 90 seconds after leaving Heathrow's runway on June 8, 2025, the aircraft's central flight computer made a catastrophic misjudgment. It decided the plane was still on the ground. In aviation terms, this is now referred to in maintenance circles as a false ground state. For a machine as advanced as the 787 Dreamliner, this was more than a quirk. It was a dangerous blind spot buried deep in the software logic. Once that false ground state took hold, the aircraft's own systems began limiting its capabilities. Engine thrust was automatically restricted, robbing the pilots of the extra power they might need in an emergency climb. The flaps, which should have shifted to takeoff positions moments after rotation, stayed in their ground configuration. Hydraulic systems, vital for operating flight controls, saw their pressure output capped. And perhaps most unsettling of all, none of this triggered the cockpit's warning systems. The flight data showed that thrust reductions began almost immediately after the faulty state kicked in. The autopilot's logic, believing it was still on the ground, started behaving in ways that made no sense for an airborne jet. Speed decayed, altitude gain slowed, and the 787 drifted dangerously close to a partial stall before the crew disconnected automation entirely and took manual control. That decision, made in seconds, kept BA217 from becoming a headline for far darker reasons. But the real nightmare wasn't just what happened in the air. It was figuring out why it happened and whether Boeing's own updates had left BA flying blind. The question of what caused this digital failure quickly became the focus. Inside British Airways maintenance and safety teams, 2 main theories emerged. The first was mechanical. A faulty sensor somewhere in the landing gear assembly, possibly providing corrupted ground-air data to the flight computer. The second was procedural. The possibility that a critical flight control software patch issued by Boeing in 2024 had never been installed on some aircraft. While the software investigation was underway, another set of findings began to cast an even longer shadow over the 787 program. In parallel to the flight data analysis, structural inspections were carried out on several grounded aircraft. That's when British Airways engineers began to find what they called cracks beneath the paint. Not literal cracks visible to the naked eye, but microscopic structural flaws embedded in the carbon fiber composite fuselage. Using ultrasonic and thermal imaging tools, they discovered microscopic voids between composite layers, a defect known in aerospace engineering as delamination. These weren't in random places either. The problem appeared in critical load-bearing areas like the wing roots and the rear pressure bulkhead. This wasn't entirely out of the blue for regulators. Back in 2021, the Federal Aviation Administration had privately flagged Boeing over the presence of shim gaps in some 787 fuselage joints. Shims are thin spacers placed between structural sections to ensure proper alignment and load distribution. If they're missing or incorrectly installed, the stresses on the airframe change dramatically over time, accelerating fatigue. At the time, Boeing had referred to the issue as a production quality concern, rather than a safety hazard, and the FAA's warning never became a public scandal. And just when BA thought this was only a software ghost in the machine, the inspections revealed something far scarier. Because British Airways' own maintenance records told a different story, in multiple log entries, the same phrase appeared over and over. Non-conforming shimming noted, deemed airworthy. In other words, engineers were finding these gaps, documenting them, but ultimately clearing the aircraft for service. That might have been standard procedure if the defects were truly minor, except the new inspections suggested they weren't. One particular British Airways Dreamliner became the case study that turned heads inside the hangar. This aircraft had flown only 9,000 cycles, a measure of takeoffs and landings, well below the expected fatigue threshold for a long-haul jet. Yet its fuselage showed degradation patterns normally seen after a decade or more of hard service. The wear was far ahead of schedule, and metallurgical analysis pointed toward poor bonding during manufacturing as the culprit. Resin voids, tiny pockets where the bonding material had failed to fully adhere, were present in more than one section of the tested panels. For an airline that had invested billions into a fleet it thought would carry it well into the 2030s, these findings weren't just inconvenient, they were devastating. They pointed to the possibility that the problem wasn't about maintenance cycles or isolated defects, but rather shortcuts taken years earlier in the production process. Shortcuts that could silently erode the airframe's long-term integrity, leaving an aircraft looking flawless on the outside but compromised at the molecular level. When British Airways committed to the Boeing 787 program, it also committed to the Rolls-Royce Trent 1000 engine. On paper, it was the perfect match. A high-bypass turbofan marketed as efficient, durable, and tuned for the Dreamliner's long-haul profile. The decision meant that the majority of BA's 787 fleet would share the same power plant, streamlining maintenance and parts logistics. But in practice, the Trent 1000 was quietly building a track record for all the wrong reasons. And if the cracks in the fuselage weren't enough, the engines that were supposed to keep the Dreamliner flying soon proved to be another ticking time bomb. By the summer of 2025, British Airways was facing the consequences in a way that could no longer be contained in internal memos. 67 Dreamliners sat idle at Heathrow, each tagged for engine replacement. The bottleneck wasn't a matter of mechanics working too slowly, it was supply. Rolls-Royce simply couldn't produce enough replacement units fast enough to meet global demand. Operators around the world were in the same queue, and the delivery timelines were stretching into months. Switching engine suppliers might have been a natural solution, but Boeing's 787 architecture had its own trap built in. A Dreamliner configured for the Trent 1000 couldn't simply be retrofitted with the General Electric GEnx engine without undergoing a full recertification process and extensive rewiring. That recertification wasn't just costly, it was time-consuming to the point of making the idea impractical in the middle of an operational crisis. BA was effectively locked into a single supplier, and that supplier was already at capacity. While BA was scrambling to hold its network together, events in the United States were about to make the situation worse for Boeing's reputation. On May 30th, 2025, an unannounced FAA audit team arrived at Boeing's North Charleston, South Carolina plant, one of the key assembly sites for the 787. The findings read like a replay of past scandals. Inspectors documented overdue inspections that should have been signed off months earlier. Quality assurance forms had been completed without the physical checks they claimed to certify. And the same technical issues Boeing had publicly declared resolved years ago, shim gaps in fuselage joins, inconsistencies in composite layups, and torque calibration errors, were still appearing on the factory floor. One internal Boeing memo, now under FAA review, summed up the situation in a single sentence: "We're applying band-aids to systems that require surgery." The audit's implications reached far beyond British Airways. By July 2025, at least 140 Dreamliners worldwide had been grounded for a mix of structural, engine, and systems-related concerns. This was no longer a matter of one airline's maintenance procedures. It was systemic across operators and continents. The ripple effects didn't stop at procurement or legal filings. Aviation insurers, watching the rising count of grounded Dreamliners, began recalculating the risk profile of operating the type. By August 2025, premiums on 787 operations had increased noticeably, adding another layer of cost to every flight that did manage to depart. Faced with mounting expenses, British Airways accelerated its internal plan to diversify the fleet mix, ensuring no single aircraft type could jeopardize the entire long-haul network if grounded en masse. The combination of engineering failures, operational paralysis, regulatory intervention, and a high-stakes corporate pivot set the stage for a confrontation that went far beyond one airline's scheduling headaches. What British Airways had started in private negotiations and internal memos was edging towards something larger. A challenge to the idea that an aircraft could be too modern to fail, and a manufacturer too big to walk away from.